Okay, so this video is just going to be filling out and how to fill out the unit circle, its relationships, and how it is all connected to our special right triangles. So the first thing that I'm going to do is label all of our quadrants. So in quadrant 1, we have positive values that are x and y. So you could say it like that, or you can simply say, okay, well, I have a positive, comma, a positive. X, comma, y, both positive, positive, positive. Over here we have quadrant 2. And in quadrant 2, we have a negative x value and a positive y value. So our coordinate points are going to be negative, positive. In quadrant 3, they are both negative. So we have negative, negative coordinate points. And then our fourth quadrant down here is going to be a positive x and a negative y, which is going to be a positive, comma, negative. Okay, so we're going to first start with degree and then go into radian, but what we're going to do first is take the circle you see here and break it up into 30 degrees. So what you have to, I'll just show you exactly what I mean. So we know that this first sliver right here is 30 degrees, and then we do know the next one is 45, but we're going to actually ignore that middle 45 line and just say, here are all my sets of 30 degrees. So this is how we're going to label, ignoring that 45. So I'm just trying to shade to show you how the unit circle can be separated into 30-degree increments or slices. And we're going to continue this pattern and go all the way around labeling in degree. So we're going to start down here at 0 degrees. We know that this is 30. Add another 30, we get 60. Add another 30, we have 90. Sorry about that. Okay, so 30 degrees added to 90 is going to be 120. Another 30 is going to be 150. And then another 30, and we know that all the way over here is 180, halfway across. So finishing this, we're going to have 210, 240, 270, 300, 330, and then underneath the 0, we're also going to say 360 for all the way around. So now what we're going to do is go through and label the radian values for each of these. So we know 30 is pi over 6. Now, I know that I added 30 to 30 degrees. So if I have pi over 6, I'm going to add it and add another pi over 6. So that's going to be 2 pi over 6. Well, 2 pi over 6 reduces to pi over 3. Then, if we add another pi over 6, we actually have 1, 2, 3 pi over 6. And that reduces to pi over 2. Sorry, I'm going to move this out of the way. So now we have pi over 2. Alright, so keep counting in terms of pi over 6s. So we did 1, 2, 3, 4, 4 pi over 6. That reduces to 2 pi over 3. 5 pi over 6 doesn't reduce, and that's the radian value right here. And then 6 pi over 6 is pi. Continuing this pattern, we're going to have 7 pi over 6. Again, doesn't reduce. I'm going to try to make that look more like a 7. And then we have 8 pi over 6, which reduces to 4 pi over 3. And then we have, what did it say? Oh, 9 pi over 6, which is 3 pi over 2. And continuing this pattern, we're going to have 5 pi over 3, because we were at 10 pi over 6. And then our last one is 11 pi over 6, and that doesn't reduce. So we have 11 pi over 6. Oh, and then we have 12 pi over 6, which is 2 pi, which brings us to our full circle. Okay, so now we're going to go back and we're going to fill in all those 45s. We're going to start with degree and then go radian. And I'm going to use a little bit darker color, like a darker red, just to show the difference in how we set this up. So we know that this is 45 degrees. We know that another 45 gives us 90. 90 plus 45 gives us 135. Plus another 45, we get 180. 180 plus 45 gives us 225. 225 plus 45 gives us 270. And then 270 plus 45 gives us 315. So just like we can break up the unit circle into 30 degrees increments, we can also break it up into 45. So we're going to do the same thing we did with our fractions for pi over 6, since we were using 30 degrees. So now we're going to do it for pi over 4. So knowing that 45 degrees is pi over 4, we're just going to keep adding. So then we add another 45 degree, and it takes us right here to 2 pi over 4. And just like pi over 6, it also reduces to pi over 2. So you know that you're on the right track. Okay, so we did pi over 4, 2 pi over 4. Now we're going to do 3 pi over 4. And that doesn't reduce. Our 4 pi over 4 brings us to pi, because 4 over 4 is 1. And then we have 5 pi over 4, which doesn't reduce. 6 pi over 4 reduces to 3 pi over 2, which we have. And then 7 pi over 4 doesn't reduce. And then 8 pi over 4 brings us to 2 pi like we had before. And I just noticed I was also missing my 0 pi at the beginning, so don't forget that. Okay, so these are all the degree and radian values to each angle in our unit circle that we're going to be working with. And from what we talked about earlier, all of these angles and radians, all of these angles were formed by our special right triangles. So using that concept of special right triangles, when we made the hypotenuse is equal to 1, we got the values that I'm going to write in. So last time in class we did this with our special right triangles, and our first value we got was root 3 over 2 and 1/2. And then at the 45s, since it's a 45-45, we have the same values of root 2 over 2, comma, root 2 over 2. And then for pi over 3, we had 1/2 and then root 3 over 2. Okay, I wanted to change those colors so that I can show you the comparisons and we can see the symmetry that's going to be created. Before we continue any further though, I want us to point out the values that we know from our terminal angles from what we talked about before. We know that at 0 degrees or at 360 that we have the point 1, 0, because each full length across is 1. And then at pi over 2, we have 0, 1. At pi, we have -1, 0. And then at 3 pi over 2, we have 0, -1. Okay, So now what we're going to do is use reflection with this unit circle to identify the corresponding points of corresponding angles. So this line right here, sorry, I'm trying to make it. This line right here gets reflected. If I reflected it over the y-axis, it goes from pi over 6 to 5 pi over 6. So it gets reflected all the way over here. So what that means then is, if I know that in quadrant 2 I have a negative comma positive point value, or I'm sorry, value, then I'm going to take the value, it's the same exact value of pi over 6, except I just changed the sign. So over here, I just have negative root 3 over 2 and positive 1/2. So continuing this reflection, I then take my pi over 6, I'm sorry, my 5 pi over 6 angle, and I reflect it over the x-axis. And when I do that, I land on my 7 pi over 6. So in this quadrant, they're both negative. So I have negative root 3 over 2 and negative 1/2. And the final reflection for this angle is 2 pi, or 11 pi over 6. So again, we have positive root 3 over 2, but we have a negative y value of negative 1/2. So there's the symmetry that we've talked about before with the unit circle. Okay, so let's continue this and fill the rest of our circle out. All right, if we go to pi over 4, here's my first line, and I have root 2 over 2 comma root 2 over 2. Reflect that over the y-axis, and that goes to root 3 pi over 4, and since it's a negative positive quadrant, my values are going to be negative root 2 over 2 comma root 2 over 2. Now we reflect over the x-axis, and those points are both negative, so we have negative root 2 over 2 and negative root 2 over 2. Final reflection is the 7 pi over 4, which gives us positive root 2 over 2, comma negative root 2 over 2. And last but not least, our pi over 3 reflections. So if we take this line and we reflect it over the y-axis, we end at 2 pi over 3, which is going to give us negative 1/2, comma root 3 over 2. If we reflect it over the x-axis, we have negative 1/2, comma negative root 3 over 2. And again, our final reflection over the y-axis again is going to be positive 1/2, negative root 3 over 2. So this is our completed unit circle. It is so important to know that first quadrant because, as you can see, everything can be reflected. And we know how we move on a coordinate grid to go in the second, third, and fourth quadrant. So knowing the signs of the values, all you need to do is reflect it your 3 times, or 3 extra quadrants from quadrant 1, and then you can fill the whole circle out.